Today we're continuing our lesson on graphing linear relations, and we're going to review everything that we covered last day. So we start off with an equation in two variables, and we know that the solutions are going to be ordered pairs. And last day we discussed two special points, the X-intercept and the Y-intercept. So that's going to be our starting point. We know that when you cross the x-axis, that point is called the X-intercept. And at that point, the y-coordinate is equal to 0. So that's going to be our starting point. So to find the X-intercept, I need to find what is the x value when y is equal to 0. So I'm going to substitute that into my equation. I'm going to clean this up. So 3x equals 6, so x is equal to 2. So the partner is equal to 2. So the ordered pair will be 2, 0. Then I want to find another special point. I'm going to find the y-intercept. So where will our line intersect the y-axis? Well, every point along the y-axis has an x-coordinate of 0. So I'm going to let x equal 0, and I'm going to find its partner y. So I replace the x with 0 into the equation, and I'm left with an equation in one single variable, and I can proceed to isolate that y is equal to 3. So now we have found two ordered pairs for this relation. Now we need to come up with two other points. In the past, we have provided you either the x value or the y value, and now it's up to you. So you have a choice of what you choose for x or you choose for y. So let's choose x is equal to 1. So I'm going to replace x with 1. And then I have an equation that I clean up. 3 plus 2y is equal to 6. When I transpose the 3 to the opposite side, it'll become 6 subtract 3, which leaves us with a 3. So y is equal to 3 over 2. So we go back to our table of values. When x is equal to 1, y is equal to 3 over 2, or I'm going to write that as 1.5 as a decimal. And now let's choose a value for y, because you can choose y and find its partner x. So I'm going to randomly pick y is 4. So I'm going to say 3x plus 2, replace the y with 4, and that is equal to 6. And we're going to clean this up. 3x plus 8 is equal to 6. Gather the x terms on one side. The positive 8 transposes, so it'll become 6 subtract 8 to get negative 2. So x is equal to negative 2 over 3. So we have negative 2 over 3, and our y value was a 4. So now we have 4 ordered pairs that are solutions to this equation in two variables. We're going to take these points, these ordered pairs, and we're going to plot them. So we have the point 2, 0. So when x is 2, y is 0. I'm going to plot that point. Then when x is 0, y is 3. When x is 1, y is 1.5. And this one here, we're going to have to approximate. That's negative 2 over 3, which is about negative 0.6. So between negative 1 and negative 2. And we're going to go up to the positive 4. Does that look right? Let's just double check. Oops, my mistake. Negative 2/3 is right here. And I just illustrated for you a mistake that I made, and I'm actually kind of glad that I made that mistake, because one of the things that we've emphasized is that an equation in two variables, when you plot the order pairs, you should get a straight line. And so when I get out a ruler and I line up these points, they should line up to form a straight line. And if they don't line up, then there's two possible mistakes that you could have made. One, you could have plotted incorrectly, which I did. I was actually plotting between -1 and -2, which was -1.66, when in fact I really needed between 0 and -1. So now I've got my point in the right spot. So as mentioned, the mistake can be in your plotting or it can be back in your calculations. But what we want to do is we want to make sure all these points line up. Now that we have done this, there are special features of a line that we like to talk about. So some people call that the analysis. So the special points are the intercepts. So our line crosses the x-axis at +2, so our x-intercept is 2. The graph or the line, this relation crosses the y-axis at +3, so our y-intercept is +3. Now the one thing I haven't discussed yet is the slope. So the slope has to do with the steepness of this particular line. Now you can draw in the triangle or you can use a formula. Now, if I'm using the formula, I'm going to go back to my table of values and I can pick any two sets of ordered pairs that I would like. Now I'm going to be strategic and I'm going to pick the first two. I'm actually going to use my intercepts. And the reason I'm choosing to do that is because the x and y values for these points are all integers. So remember, starting with our formula, the slope is the difference in the x values over the difference in the y values. So I'm going to start here with this first point. So the y value is 0 and its partner is 2. So I'm going to put the 2 in the denominator, put in my subtraction signs, and then moving to the next point, 0, 3, the y value is 3 and the x value is 0. And when we clean this up, we're going to get -3 over +2. So we have a slope of -3 over 2. So the first thing I want to do is I want to check. I've got a negative sign. That makes sense because this line is heading downwards. It has a negative slope. And if I pick points that I can see on the graph, such as this point here, to go from this point, the y-intercept, to the x-intercept, I had to count down 3 squares. So that is a negative rise. And I went forward 2 squares. So I have a positive run of 2. So I have verified my slope and I'm confident that I have the right answer. So let's look at another example. Okay, this time I've introduced a negative integer. Same idea, we have a relation in two variables and we want to find the two special points, the intercepts. So that's when y is equal to 0 and when x is equal to 0. So I will always want to show these two key points on my graph. So I'm going to do my calculations down below. Okay, so when y is equal to 0, we'll have 4x plus 3, replace y with the 0 equals -12. Clean up the equation. We have an equation in one variable. Divide both sides by 4 so that x is equal to -3. And for the next one, we are going to replace x with the 0 and we're going to solve for y. So we're going to get 3y equals -12. So y is equal to -4. Now that we've taken care of the intercepts, we now need to come up with 2 additional points. So again, it is up to you. And we're going to ask that you choose one value for x and find its partner y, and then choose a value for y and then find its partner x. So again, pick whatever you want. I'm going to choose x as 1. So I'm going to replace x with 1 into the equation and clean up and isolate for y. So we're going to transpose the +4 to the opposite side, gather like terms. So y is equal to -16 over 3. And you're probably wondering, how are we going to graph this? We'll talk about that in just a minute. Let's finish our table of values. And then I said the next thing I want to do is I want to pick a value for y. So let's look here. We don't have a y value of 2, so let's try y is 2. So I'm always picking a value that's an integer, and then the partner sometimes works out to be a fraction. So we have 4x plus 3. Replace the y with a 2. We're going to take care of the multiplying. And then we're going to transpose, gather like terms, divide both sides by positive 4, and we're going to reduce that to get negative 9 over 2. So now we've got our table of values. And now we're going to have to move down a little bit. And now I'm going to plot these points. So I'm going to go to negative 3 and 0, x value of 0, and a y value of negative 4. And we have 1 and negative 16 over 3. Now, 16 over 3 works out to be approximately negative 5.3 as a decimal. And so at this point, you are welcome to take your calculator and come up with the decimal equivalent, and that will help you to visualize where that point is on your grid. So when x is equal to 1, my y value is negative 5.3, so it's down here. And the next one, when x is negative 9 over 2, now negative 9 over 2 is equal to negative 4.5. So when x is negative 4.5, my y value is 2. Okay, so now I've graphed my order pairs. I'm going to get out my ruler. This is looking good. Everything seems to be lining up. You definitely need to use a ruler here. We're going to connect those points, and then we add arrows on the end of the line because this line continues in both directions, and so that's what the arrows are indicating. And now we're going to do the analysis of the slope. Again, pick any 2 sets of order pairs from your table of values, and I'm going to jump right in. I'm not going to write out the formula. So I'm going to work with the first order pair at the beginning, add in my subtraction signs. This one here, the y value is negative 4, and here it's 0. So when you clean this up, you get negative 4 over negative 3, and a negative over a negative gives us a positive. So we do have a positive slope. Now let's double check that. There is a mistake there. These 2 negatives make that a positive. So in fact, we do have a negative slope, negative 4 over 3. So as I go along, I want to be double checking my work, because the fact is, when I look at my lines, this slope goes down. So it has to be a negative slope. So if I end up with a positive answer here, I know I need to check my work. Somewhere or other, I've made a mistake. So as you're going along, check your work. Ask yourself those questions. Does this make sense? And the last thing we need to do now is to identify our X-intercept, which is at negative 3, and our Y-intercept at negative 4.